Hi guys, we're going to talk about parallel and perpendicular lines. Before we do that, we need to talk about intersecting lines. So intersecting lines are two or more lines that cross each other. So here we can see the orange line AB and the purplish line PQ are intersecting at this point in the middle C. So we could write that as line AB intersects line PQ at C. So next we're going to talk about parallel lines. So parallel lines are two lines on the same plane that never meet or never intersect. And they have the same slope. So here on the left-hand side, we can see that we have line AB and PQ, and they look like they are essentially pointing the same way, and they have exactly the same slope. So the symbol that we could use to show that they're parallel lines is just drawing two vertical parallel lines, and we draw these symbols. An example in slope-intercept form of two parallel lines that have the same slope could be, so here we have y equals 3x plus 2 and y equals 3x plus 5, and we can see that our slope, which is our m in y equals mx plus b, is both 3, so they have the same slope. But they have different y-intercepts, so we know that they're two lines that will never meet. Next, we're going to talk about perpendicular lines. So perpendicular lines are a special type of intersection where they intersect at a 90-degree angle. They have opposite reciprocal slopes, and we'll talk about that in 1 second, but here in the picture we can see that we have the purple line PQ and the orange line AB, and we have that little box next to the point where they intersect C that tells us it's a 90-degree angle. And the symbol that we use looks kind of like an upside down T, and that means that line AB and line PQ are perpendicular. So let's show opposite reciprocal slope in slope-intercept form. So we have y equals 3x plus 2 and y equals negative 1/3 x. So opposite means that they have different signs. And reciprocal is when we flip the fraction. So we want one positive and one negative. As we can see, we have 3 and negative 1/3, and we just flip the fraction. So remember that when we have 3, we can always, any whole number can always be put over 1, and if we flip the fraction, we go to 1/3. And different signs here means we want one positive, one negative. So our first example is asking us to write an equation to a line that is perpendicular to y equals negative 5/3x minus 2. So if we saw in the last example, we can have the same y-intercept because that doesn't matter. That's just where they would intersect at a 90-degree angle. We just need to make sure that we flip the fraction and get different signs to have an opposite reciprocal slope. So if we're going from negative 5/3, we want to flip it, so we get 3/5. And in this case, because the first one was negative, we just want a positive 3/5. So the answer could be y is equal to 3/5x minus 2. The y-intercept is not as important. What's really important in the criteria that we put up there was that they have opposite reciprocal slope. So our next problem is asking us, given these 3 points A, B, C, and D, what types of lines are A, B, and C, D? So that's really just asking us if they just intersect, they're parallel, or if they're perpendicular. And the big criteria that we need to look at is the slope. So we're going to start by finding the slope between the 2 points A and B. So just starting off with A and B, we get 4 minus 2 and 6 minus 3. So we get 2/3, and we get a positive 2/3. And then we're going to move on to C and D. So we get 2 minus 0 over negative 3 minus 0, and because we're subtracting by 0, nothing changes, and we get 2 over negative 3. Now we do see they have opposite signs, one's positive and one's negative, but it doesn't look like we flipped the fraction, so we're just having opposite slope. We don't have an opposite reciprocal slope, so they are just intersecting lines. So this problem gives us a good amount of information. It says we want to write an equation to a line in slope-intercept form for a line that is perpendicular to y plus 3/4x equals 17 and passes through these points to negative 5. Well, first of all, it's not giving us given to us in either point slope or slope intercept, so we're going to have to subtract by 3 over 4x on both sides to get y is equal to negative 3 over 4x plus 17. So now we have our slope, and we're looking for perpendicular slope, so we want opposite reciprocal. So we're going to flip that fraction to get 4 over 3. Because it is a negative, we want to make the other one positive, and we actually have our x1 and y1 over here, so we're going to use our point slope form, and we'll plug it in, so we get y minus negative 5 is equal to 4 over 3 times x minus 2. So we have it in point slope form. The only thing is we're going to have to make this a positive 5. And I'm going to flip the page. And our equation's y plus 5 equals 4 over 3 x minus 2. Now it said we want in slope-intercept form, so we're going to have to start solving for our y. Because in slope-intercept form, the y is by itself. So we're going to start by distributing, and we get 4 over 3 x minus 8 over 3. And then we can subtract 5 on both sides, and we get y is equal to 4 over 3x. And let's go ahead and do 8 over 3 minus, if we want to turn 5 into a fraction, we put over 1. To get a common denominator, we multiply by 3 on top and bottom to get 15 over 3. So we're doing 8 over 3 minus 15 over 3, which is going to give us negative 7 over 3. So our final answer, and I just made a mistake over here, negative 7 over 3 is y is equal to 4 over 3x minus 7 over 3. And that's the end of this video.